Okay, let's get started so that we have a possibility to retry this if the recording fails. As you already know from the schedule, my name is Jussi Kasurinen from Tampere University of Technology, and I'm here to give you a presentation on the topic test process and test process development, which also is the topic of my dissertation work. Ongoing work with the intention of having the dissertation defense in coming fall. Okay, so to start the presentation with some some teaser to give you an idea on why this is important thing. Here's some interesting facts on software testing. In United States alone, at the turn of the 21st century, 21.2 billion US dollars were lost annually to the direct consequences caused by insufficient testing, meaning that the errors lost, missed by the applied tools, errors missed because there wasn't enough time or money or people to do the testing, or because corners were cut on the project timetables. And this is only the direct costs of the developers. If we take into account the customers and organizations using that tool, private people, other companies, it grows to $55 billion. And well, obviously, if the losses are high, then there's also the consideration that actually testing, even though it's in the traditional waterfall approach, it's the last thing to do before launching the product. It's also the most costly phase of software development. But of course, it's a costly thing. Development is costly, and organizations want to have the product making money as soon as possible. And in fact, there's a debate ongoing on what is the right amount of testing resources. In fact, only 20% of the so-called optimal is actually really needed. The optimal means that if organization has two testers and they think that they would have use for three, or the three testers would be their ideal amount of people, then two testers is 67%, 2/3 of the optimal resources. But 20 is enough if it's organized efficiently. Also, testing has a large influence on the profitability of the product whenever it's launched. It's the customer satisfaction, returning customers, public image, and of course the costs of fixing errors after the software is launched. It's costly, it's time consuming, in some cases it's even embarrassing. So anyway, here's the quick structure of this presentation. The background, what will be discussed today, and continue by giving a quick introduction on my dissertation topic as an example for those students who are currently working at their dissertation, and to give a quick overview on what are my credentials, why am I here today giving you presentation on software testing. And the third topic are the concepts, the central concepts, themes of my dissertation. And on the fourth phase, I present some of my study results, give an idea on what kind of test process components, test process results we were able to get during this study. And the last part is the what to remember, the conclusions. It's a quick recap on the things I discussed today. So if you are going to fall asleep, try to wake up for the conclusions, because that's the part that puts everything together. So today's topic, well, that's easy. It's software testing, including but not limited to test process, personnel, tools, strategy, case selection strategy, policies, automation, self-assessment framework, process development, process ISO, IEC 29119, ISO IEC 25010, other standards, organization, certifications, completion reports, monitoring and control, blah blah blah. Software testing in organization. That's today's topic. That's what we are going to discuss. That in all its organizational glory. So that's the background. If we are going to keep this pace up, we will be all here leaving home in 15 minutes. But let's go to introduction. So, why are we here? Well, this dissertation work is a brainchild of a ESPA project funded by TEKES and done with a group of companies and other organizations. It's a joint research project between two universities, us here at Lappeenranta and Aalto University, Otaniemi, Helsinki University of Technology guys from Sober IT Software Engineering Institute. Here we can see how our ESPA was constructed. My dissertation discussed the organizational level, one company level organization. It's called MASTO project. And SQUID goes within the details at project level, observing the people within the organization. So I'm not actually giving a presentation on how people work at their personal workstation. I'm giving a presentation on how testing as an organization, as a one process works. Anyhow, so what are these organizational testing aspects? What is there in testing that can be discussed in organizational context? Well, as we can see from this table, pretty much anything that comes to mind. Here are the different layers of one international standard which defines test process, meaning that there's a test policy, test strategy, test management and fundamental level of testing, which means the actual testing work. And we will come back to that. So if my concept was in organizational testing aspects, of course it's within this testing strategy area. And the main idea of test strategy is to answer how, where, who and when. And if we take a look at the different compositions of test strategy, for example in ISTQB, the upcoming international standard and test maturity model integration version 2. We come up with a rather daunting list. There's of course testing tools, testing methods, how software is tested, testing personnel, what is the organization, what the testers should know, what are the responsibilities, how independent the workers are, test case design and selection, test case design principles, how the cases are prioritized over each other, how the risks are managed, and quality criteria, the entry and exit criteria for starting and ending testing, quality assurance and quality control within the testing work, and standards which have to be complied with. And of course, as in many things, we also have this interesting other box here, which can be several things that are basically from outside the testing process itself, like production method, customer knowledge transfer between customer and developer, and possibly outsourcing and such. Okay, so there's actually quite a large amount of topics to cover within one dissertation, so we decided to approach the situation by working on these larger groups, which were defined based on different things, the different certificates and standards say that is the strategy. So because this is a PhD student course, I'll give you some idea on how my work went. Of course, I started at the fall of 2008 by doing a literature review and starting my data collection work. We interviewed, well, actually more than that, but we interviewed tens of organizations, several organizations in 4 interview rounds, and we also did a survey at one point. There were qualitative studies and quantitative studies and a researcher exchange at Lund Tekniska Högskola. And of course, now I am finalizing my dissertation based on the works and my publications and collected data. This is actually, and all the time I was giving out master's and bachelor's thesis works on some things I was concerned over. So overall, I'd say that this is the optimal way of doing it. I know that it's not always this clear cut, but I think that my work was very well in schedule. So, our study method to approach the test process was in qualitative grounded method study with 12 organizations at first rounds and 10 organizations at the last. And as a qualitative study, our main approach was interviewing people. And when we take an interview on teams which cover the test process, we collected data on the organizations, how they do testing, what are the, how they understand or apply different components, test automation, explorative testing, things like that. And when we had the interview completed, we did a transcription on it and compared our notes taken during the interview and started a codification process where we made a list of different things that came up. Well, enhancement proposals, strategies for testing problems, and collected them in our open coding phase to get the interview data to a form where it can be observed easily by applying tools like Atlas TI, which is especially designed for this interview codification. Okay, so now that we have categories, problems, enhancement proposals, test strategy, test policy issues, management issues, we did the actual coding on it, where the categories were the codes within categories were connected each other based on what's relevant to what other thing. It formed a kind of a spider web where things that are relevant to each other are connected together. And after that, selective coding, where we selected a certain problem from the data and took a part of let's say a few categories and did a selective coding where we wanted to find the core category, which was the most best category to explain all the observed phenomena. And based on that, we made a hypothesis, or used literature review, observations, formed a group of arguments which were able to explain how parts of this observed phenomena happened. And if the phenomena or observations were strong enough, we were able to create a grounded theory, so to say, an explanation which explains how the observed phenomena happens. And of course, now that we are talking about qualitative studies, it has to be remembered that we are not actually formulating a mathematical theory, but more like an explanation which is not directly generalizable beyond the study organizations. If these results are used in another context, not in this particular study, they are more like suggestions, considerations, and let's say key figures that should be observed from the organization where we are trying to apply the ideas and concepts from this study. And of course, we also did a survey with 31 organizations to get some statistical data and be able to compare the interviews against the surveys. So we did a focus group interviews with 12 organizations from the Finnish software industry. Small to medium, national and international, actually also large size organizations, and they varied from 3-man test consultancies to software product developers to organizations building embedded software for the hardware platform and to public sector. So we applied a theoretical sampling where we tried to pick organizations which would be representative of many different types of software organizations. And we did a survey with 31 organizations, including those we interviewed, those 12 we interviewed the first time, and also later few additional interviews with other organizations. And of course, because QUID at Aalto University was our sister project, we were also able to use their data in few occasions where they had enough overlap to actually be useful to us. Okay, so what did we ask the people? The survey themes, on the first 3 rounds, here, and here, we had the 12 focus organizations, and on the second round we had the additional survey going along with the interviews, and on the fourth round we had 10 organizations which were interviewed for some validation data. This 10 was not a subgroup of these 12. There were some changes because this was organized at 2010 and these were done at the late 08 and early 09. But anyway, we interviewed on the first round software designers and all people responsible for software design in the organization, because not in all organizations there's not a separate software designer. On the second round we discussed with test manager or project leader who is responsible for testing or developing one particular project or product. And we also interviewed these people on the fourth round. On the third round we talked with the actual testers or people who are responsible for important testing phases. In some organizations there are no separate testers, but people who are responsible for doing testing. So the interview themes, as our today's general themes, so were the interview themes very, let's say, large scale. design and development methods, testing strategy and methods, agility standards, outsourcing, perceived quality, similar things, testing, test process, software quality, testing methods, testing tools, customer in testing, delivery models, new software development concepts, all sort of things that are related to the organizational concepts I introduced earlier. And the overview of the organizations, there's not much to see there, but there's a large international, small national, and everything in between. What did we then publish based on that? It's a huge area. It's possible to get lost in a sea of conflicting data. So we did a approach which was based on these larger categorizations. First, we did a group of focused publications which discussed one particular category: testing tools, methods in organizations, testing personnel. Well, actually, testing personnel was covered in the same publication that talked about testing tools, but really focused set topics which discussed the one of these categories in the practical organizations. And after these areas were established, we did two additional publications which discussed the actual test process itself on a large scale, from the viewpoint of the process development and from the viewpoint of creating a self-assessment tool to help organizations develop their testing work. Okay, so that was the introduction part, and we have used a bit over 20 minutes now, so I think we are pretty much in time here. So what makes testing go? Well, first of all, test process is a socio-technical system, meaning that it's not completely definable by one aspect, such as application of mechanical tools, application of automation, nor is it completely social activity, or it has information. It has several actual products in it. The production of artifact here is obviously the testing work itself. It's related to money, tools, natural resources, parts available. It has humans, transfer of knowledge, and science behind the testing work. And of course, it's related to the distribution networks, the customers, the possible internal requirements which come from the regulations, and well, in the banking sector, of course, the regulations can be almost anything. And of course, in the application domain, there's this use of the artifact in user practice, which has to be thought in when testing the product, and how it is joined to other similar works, how it's repaired, how it's maintained, and the cultural meaning. Well, in software industry, not much that, but it's a still concept. So overall, the test process cannot be considered strictly from the viewpoint of mechanical work, but it's not information work. It has to be all this, or it's irrelevant to start studying. So in testing, of course, the idea is to enable the quality of the product, which itself is a bit hazy area to define. I mean, there are several ways to define quality. Well, for example, there's a Garvin study which has 6 different meanings for quality. One, the first, let's say, metaphysical explanation is that it's an innate excellence which cannot be really pinpointed or defined, but the user or the customer knows when the quality exists in a product. Just knows, but cannot tell you why it is that. From the more engineering viewpoint, there's quality models. For example, this ISO 25010 draft, where the software product quality is in fact a composition of 8 different attributes, characteristics, which all of them are defined in a group of smaller sub-characteristics, which are more or less measurable or at least estimatable from the software product. And this is actually how we understood the quality in our work. It's a functional stability, reliability, performance, efficiency, operability, security, compatibility, maintainability, and portability. By the combination of these is the software product quality in this study. So, these quality attributes make the software quality. In software development, the aim is to verify the quality objectives, meaning that there's a design for product and the development creates the product based on the objectives. And in testing, the idea is to validate that these objectives, design objectives, quality objectives are actually exist. That's the raw version of it. Of course, it's not that clear cut, but the basic idea in the work is that. So then, what is testing? Well, I'm not going to go into too many details over this test process model, which is the backbone of my dissertation. But basically, the model has 3 layers. It's the organization, which steers the activities from the upper level. There's the management in project, which manages the project level application of the decisions made by organization, and fundamental level, where the actual testing tasks are performed, like the management in project level as defined. Basically, there's 4 things that need to be defined. A test policy, which says that what's the main objective of testing, why and who does it, why is the testing done and who does it. The test strategy goes into more details, but it's basically a framework which tells how the testing should be done. What should be tested, when should it be tested, how it should be tested, and where it should be tested. And these ideas are made real or put in application in practice at the test plan, which on project level defines what is tested and when it's done. And when the testing is done based on plan, there's a test completion report which supports the management and the organizational level to steer the testing work in the later phase. And in this model, it's actually important to understand that this testing work here does not mean the context of the waterfall model, where testing is just one phase after design and development. In this context, the testing is all the tasks needed within the project, whether it's a design of what should be tested, what's the quality objectives of the product, in the development, how things are developed so that they are testable, or how the testing is addressed in development. And well, in general, test process, the idea is that these 3 layers are connected to each other, and things happen within levels, and there's processes which do different things. If we see here, the original idea is that there's a policy level, strategy, test management, and test work. And here, these parts are from project. There can be several projects in one organization, and these are come from the organizations, and of course there can be only one organization within organization unit. And every lower level creates feedback to the upper level, and every upper level steers the work in the lower level. Here are the and in each layer there's processes, which, for example, here's the test plan. The test plan is created here. The test strategy is created here. The test policy is made here by using IT policy and management. And here are the affecting factors which affect how the test strategy should be created. This is actually the thing that we are looking into. And on the test management, test monitoring and control, and test completion reports and actual testing work here, getting the testing environments to work, and test design and implementation activities at the lower levels. But anyway, it's a rather simple model when it's working. Here's the organizational part. We define how we want to do testing. Create a test policy, test strategy, test specification, and which defines the overall management and control from upper management. Then there's an update process, possibility to change the things accordingly, and just keep the test specification up to date. On the other hand, at the project level, here is this is here, and the strategy and policies affect the everyday test management within one project, and there can be several projects within one organization. And there's the test planning and the development of test plan, monitoring and control changes if needed, and the test plan goes here, where the cases are designed and implemented, test environment setup, test execution. If there's something problem, the test cannot be done, or there's something missing, then it creates feedback, the test plan is changed, and the work starts again. So on the final product, when everything is done, is the test completion report, which is given back as a feedback to this organization, so they can go through the revision work and decide what changes are needed. That's basically the idea of ISO IEC 29119 test process model. And here it's even further simplified. There's organization, there's projects, and there's the organization level management, gives strategy and policies to the project level management, which does the test plan, test management and control, test completion, and hands it over to test execution level, where there's static things that are always done, and dynamic things which are done when they are needed or when it's time to do them. And the organization gives order to lower levels, and lower levels give feedback to the upper levels. Okay, so we don't have to go to detail to those processes, but on each box, each area, there are certain responsibilities and activities which are needed to actually keep the work, keep the model working. So, the main points from test policy is that it's short. It's an executive level document, defines test management commitment to testing. It's a non-technical and short description of what or why things are tested, and who does testing and stuff. The strategy is the part which has all the different components I showed earlier, and it actually goes a bit more into details. It's not project specific in a sense that it actually gives a framework which allows the project management to get some creativity, but it's tailorable to use different types of projects. And the test plan, well, it's the basic software engineering thing. It defines the different cases and who does what parts are tested, and so on. And test completion report tells the whole story later. And well, in this work there's also one term which has to be explained. It's a software criticality. It's well, it's a not very well understood term, but it's basically it's a scale from 1 to 5, and it expresses how badly things go wrong if the software fails. The level 1 is that, well, no, or user irritation. User have to reboot the game system. User have to reboot the phone, for example. 2 is the small economical losses. The ticket fails to print. You have to pay your bus ticket twice. No record of sale is made. You get scratched. Well, broken memory stick, and you have to go back to the store, and they say that this wasn't bought from them, type of thing. The third level is significant losses. It means that there's an entire store that has to be closed down because their cash register system completely locks up, or the product stock has to be scrapped in, let's say, a small factory because there was fault at the parameters and there's no bottom at the barrels, sort of thing. That's actually because that's actually a really important starts to mean something at that level. On the 4, it means that there's a bodily harm to the user or people using the software who depend on the software, or great economical losses, meaning that the operator loses hand. The people who are riding the system may get injured, and the production line has to be closed, types of things. You have to make physical repairs at, let's say, factory, because this system has broken the production line. And the last and the most severe level is, of course, the 5, which means loss of human life. And the operator or people depending on the software system are killed. The airplane shuts down its engines mid-air. The elevator drops like a stone from the 16th floor to the basement. Well, there's also it's also debatable that is the loss of a few humans is it comparable to the great economical losses, meaning that if there's an entire factory that closes down and it may cause when it breaks down, it may cause a catastrophe which may claim human life or cause severe losses. Is it the same level of severity? But in our, well, in this reference and basically in my mind, the loss of human life is always worse than actually something that can be paid. Let's say that. So there's the concepts, there's the quality, there's the test process itself, and there's the criticality of the software we are testing. Those are the concepts that and the organizational components that actually make the test process. What it tries to achieve, the software quality, what it does, with what tools, and so on. So let's see what we were able to find out from the organizations when we went to have a discussion those people. So, first of all, the application of standards in testing, it was, well, less than we actually expected. There are in-house standards, self-designed guidelines and such in several places, but overall they were not formally used that much. Some parts, some practices are adopted, but in several cases the organizations did not have a formal standard. They were very positive towards them, different certification programs, ISEP, standardization, and ISO 9000, but only in 61% of the companies they had something formal. And 13% used some official measurements or applied parts of a formal process, but did not actually follow anything to a close degree. Okay, so we are talking about quality here, the perceived quality, meaning that the quality that the organization who is doing the software sees or thinks. So, how is the quality on test process? Well, first of all, we did a survey on the different levels of test process. Based on the results, it seems that the organizations are pretty harmonious in their different test process levels, meaning that there are no great variations between, let's say, management of the test process or executing the testing work. They are pretty much in average on the same level in organizations. It's not common to have a great testing work but bad test management or vice versa. But what was actually interesting was that in the software organizations which develop software, the quality, in their opinion, is definitely more based on development work than testing work. The testing work is where the quality is confirmed. Well, let's say quality potential is made real, but the source of quality is in development. And based on the ISO quality characteristics, our first idea was that the different characteristics are important to different types of organizations. And there are some characteristics which are basically irrelevant in some sort of organizations. For example, let's say transferability in system that builds software to their own hardware product, or installability, the old name for it, or compatibility in a system that comes to a hardware system. It doesn't have to be compatible to anything else but the system it's used in. But that actually turned out to be not true. In all organizations which were surveyed, every attribute was at least somewhat important. We had 31 organizations which did the quality characteristic assessment, and only in 9 individual assessments, less than 5% of the assessments, the organization said that this characteristic is not important. This is something that it is irrelevant to us. And what's more interesting is that there were only a few variations within the quality characteristics. The functional suitability and reliability, security, are the most common things that the organizations consider that they have very good quality on these characteristics. And on some areas, the transferability, the maintainability are the less well considered, but also they are important to organizations, and organizations consider them to be quality characteristics which are first of all important to them, but also something that they are doing well. Okay, so what was the things that, based on the survey, affected the perceived quality of the software? So what are the things in testing work that make the quality better? There were three things which basically were which had statistical relevance in the results. It's first of all, it's the trust between the customer and developer. That was really important thing for organizations. If the specifications are distributed freely, things are discussed, and the information is available, it's really a thing that helps with the quality of the software product. Another thing was the existing conformance with the concepts, the ideas presented in the test process model. If the workflow has feedback system, and there are plans, and there are certain decisions and documents, and there's assessment and the possibility to change things, it eases it helps quality. And of course the elaboration. Organizations which have identified and communicated the quality characteristics they feel important also are more confident that they are actually doing things correctly. That's actually important because based on the same quality models as Garvin, as discussed earlier, the Garvin models, there's a discussion which we also noticed that different people in software organizations consider different quality characteristics important. For example, the installability and updatability types of things are important to, let's say, a software designer, and he says that those are the important features, quality features of our software. But when you go to talk with management, it's the security and usability. When you go to talk with the tester, it's the usability and reliability and stability. So overall, if the organizations have identified what they want and communicated them, it actually helps the quality because everyone knows what we should be trying to get. Okay. On the other hand, there were some quality considerations, some concepts that, based on this, so to say, common knowledge, may seem important things for quality, but don't exactly affect that much. The most important thing was the end product criticality, which I explained earlier. The rocket control system obviously is tested more thoroughly than a mobile game, but actually the preferred quality comes from the domain of the product, not from the criticality of the end product. Meaning that, well, the user netbank and stock exchange core, they have a similar quality objectives based on the characteristics. The quality characteristics stay the same, whether the end product criticality rises or is lower. It doesn't affect the important quality characteristics that much. The development method also was observed to be a non-issue. An agile product can be as high quality as a traditionally made, meaning that the development process, the development method actually has really small role in a test process, in a sense that the test process can be organized in almost independently from the development. Of course, there's a scheduling issues and such. You can test something that doesn't exist, but on the other hand, you can arrange your testing work, the way you test things, in any way, as long as the product arrives on time to your testing, to your test process. And of course, we also tested the open source, but we were unable to find the reasons, anything, we were unable to find any affecting any effect between open source and closed source. And the final thing was outsourcing. In large organizations, the outsourcing was actually seen as a way to help quality, because unnecessary things are thrown out from the development, and they are the headache of some other people. The large organizations actually thought that the outsourcing helps them to focus on important aspects. In smaller organizations, they weren't as positive towards outsourcing, but outsourcing wasn't a major player in quality. Okay, so what were the other thing we discussed was the most common test process problems. The organizations were told to tell us what were the problems with the testing work. And they were test automation, they just don't have enough time, money, or both to implement relevant test automation. And agile development, it's hard to convert to using agile. There's a contractual obligations which require that certain things are delivered to customer, and with agile development, it's hard to actually set, let's say, test plan in stone before moving to testing phase, because the development is constantly living. Of course, that means that there's also uncontrollable featureitis, which is a term meaning that when there's a possibility to actually react to different situations, it also tends to cause that the people like to react to everything. The program keeps getting larger and larger and more complex, meaning that it causes problems later on in the development. And of course, it's something that hasn't been done earlier, so organizations find it hard to get the mindset of doing things that way. And as interesting as it was, even though outsourcing was not considered a quality problem, it was considered a problem in general. The organizations cannot say that they cannot do outsourcing because no one else has the hands-on experience of the system they are developing. Of course, it has to be remembered that there's a few things to consider here. First of all, some forms of outsourcing, of course, require tacit knowledge, meaning that you cannot start testing or developing software for, let's say, legal assistance if you don't have any idea on legal procedures. But in general, if there were possibility to outsource some parts like printing reports or getting this PDF conversion tool or a recording tool, then it was outsourced. But the outsourcing was problematic in areas where there's a huge requirements for tacit knowledge, insurance systems, healthcare, legal things where legal jurisdiction lawyers are used. Anyway, so how the organizations then thought that they could help their test process towards more feasible or usable system. Well, the one way they saw was that they could acquire new tools. That they had this instinct that they could have better tools to support their work. Could add tools to help documentation, quality control portals. Also, possibly create automation so that they could start doing something else besides regression testing, module testing, and get 3D testing resources to something that's more higher level, requires more abstract thinking, and would allow them more freedom to focus their human resources to something else than testing module interfaces. And the last one was in documentation, that there are changes and things change so much that organizations thought that they could actually use better documentation to be able to track the changes and get information to all stakeholders, to transfer the knowledge between the developers and testers and customers and managers and testers and so on. Those three were the most important ways the organizations considered that their testing process could be developed. So overall, the amount of resources was that in best organizations, the testing work was almost completely automated. Only 10% of testing was done by hand, but on the other hand, the average was 10%. So even if some organizations are able to apply test automation heavily, so most organizations only use it as a tool for some specific tasks. Similarly, in agile development, only few organizations did everything agile, and most organizations just used agile development as their approach for secondary projects such as patchwork or adding features. The most important and most interesting number in this table is the amount of testers per actual need, meaning that organizations have 75% of the resources they consider optimal, and they use 1/4 of the project time in average for testing, where the testing is done as a main activity. Those numbers are actually higher than was originally considered, and especially the 75% of the testing resources is important because the literature suggests that 20 is enough to get acceptable amount of testing. So 75 is actually quite much. Let's keep forward a bit. It's on testing strategies, how the organizations actually approach testing. The most interesting part was that there's actually two prevalent strategies: the new features first and the critical features first. Meaning that basically the test case selection, test case prioritization is a risk versus design. It's basically how much things will cost us if this program breaks, and what we have to test before actually make it certain that the customer gets what it's paying. And there's actually it's rather clear-cut decision. It affects several ways. Who designs the tests, how the software is developed is somewhat interesting. Mostly because the customer influence is in risk-based selection in testing process at the latter part of the development, whereas in other places it's in the design. It's in the design, meaning that the customer actually has a lot influence on how the software is designed. And of course, there's some other influences, meaning that the design-based approach is closer to the traditional approach. There's the policies and decisions are affect in design-based selection to a large degree. In risk-based, it's more that the organizations are allowed, the testers in the project are allowed to design more freely what they want to test. And that's interesting result because it really it's really two simple stereotypical categories. Of course, these aren't clear cut so that you are either this or this, but they are two really strong stereotypes available. So if they do that when they design their testing work, then how do they actually develop their process? How do they adopt new ideas, concepts, and new approaches? Well, the short answer to that question is that, well, the organizations don't. Status quo is the preferred state, and similarly as presented by Dubois in his study. The organizations do not actively seek out new ideas. It has nothing to do with the organization's size or the company that owns the organization unit. It has nothing to do with that. It's just that the process development is always a risk that costs money regardless of the results, so organizations tend to avoid it. They go even so far that even if the organization collects feedback from how the process works, as similarly as presented in the ISO standard, the organizations may discard these ideas and complaints by justifying it in a sense that it's good enough. We don't have to develop ourselves because this is still good enough. And of course, it also doesn't help that process development needs preparation, it needs work, it requires effort, which in many places is not considered productive work. So here is our grounded theory, what we came up when we did a analysis on how organizations develop themselves. They don't tend to try out new ideas. That's the main point we have to remember here. There is a possibility for sporadic development when the inconveniences, the differences between the development and testing, or possibly the pressure from development to test certain features that we haven't currently been testing, becomes too great. So then it's the management role. Either they put effort to process development and try to get new method, new idea into the existing test process, or they try to get some better form of activity out from here. And when the time goes on, the inconveniences keep on coming, and if the inconveniences are acceptable, nothing happens. But when it happens, then your management may put effort on trying to reduce the inconveniences. Okay, so but that's actually, based on that result, it's actually interesting to see that test strategy, test policy, and test plan, they exist in every organization in some form or another. And all organizations actually define someone whose role is to create a test plan. Meaning that overall the test documentation and the basics, fundamentals of the 29119 model are feasible to implement in basically any test organization. In practice, it seems that the project level is more down to earth, closer to the actual practices today than the organizational level. But overall, the test process is applicable. So, the last thing we then did based on these results was that we defined a self-assessment framework in which we tried to help the organizations to assess what they should focus on when the inconveniences are enough to warrant trying to develop themselves. So we combined existing maturity model levels with the ISO 29119 processes. And here are the processes, and here are the maturity levels. Basically, the 0 is the level of not doing it, this process. 1 is the basic level, meaning that the organization does the development in a formal, generally agreed way. 2 is that this process aims for cost effectiveness. 3 means that it aims for risk management, and 4 means that it's a continuously adapting process which follows the ideas presented in this test standard. And what we can actually get from this self-assessment framework when the assessment is done. First of all, we get individual assessments of each process. So it's possible to see what processes are lacking and consider how these particular things should be developed. And also the general maturity and conformance estimation for organizational. So let's say that if the profile would be like this, the overall level would be something that the test process is cost efficient and it's closing up on risk prevention. Of course, it has some weak points, it has a really strong points, and it's somewhere here in between. And if this is the level the organization wants to have, that they are mainly they are cost effective, and in some areas they are able to avoid risks, and they should probably develop their organizational activities, OP, organizational process, to be closer their general maturity level or their objective. So yes, here are the processes, all the OTP test management and control process, which are then assessed individually here based on the activities and things they do. And well, here's the same model. We can see here that there's different observations based on the activities which are related to the responsibilities of the process, and there's development suggestions like active organizational level management, activate organizational level management to address the test process needs in decision making, and define more clear organizational level policies and strategies which would put this to there, possibly even there, and make this process which is lagging behind more closer to the general line. And in the we tested this out in few organizations that participated on this study, and the general consensus was that the tool, the concept for this tool, self-assessment framework, was positive. It's of course it's a proof of concept, so you can't really say that it's not yet completely usable. It's not supposed to be, but it's a step in the right direction. The organizations generally thought that it's a good approach, but it needs further refinement. For example, to establish the better division of different maturity levels and such. But anyway, time to go to conclusions. 29119 in a nutshell is that there's a company level activities and there's project level activities. And all the upper steer the lower levels and all the lower levels report to upper levels. There's 4 main concepts: test policy, why and who, test strategy, what, when, how and where, test plan and test completion report, which both are used in the project level and report to organizational level. The 2 organizational concepts, organizational test process concepts pretty much include everything on the higher abstraction level, and meaning that it's the objectives, criticality, quality standards, customer participation, outsourcing, working methods, resources, tools, personnel. Everything is part of the test strategy and test process. So things need to be thought out. So, and on the other hand, is this new approach, 29119 test process model, then usable? Well, based on our data, our study on the organizations, it is. However, it has a few problems. It does not offer any help for adapting to the process model. The model is overly detailed. In real life, things aren't that clear-cut as the model likes to think they are, and the model is top-heavy. There are too many roles, responsibilities, and activities tied to organizational management, and it takes several activities from the project level, which in practical organizations has larger role than in the model. So, what should I remember from this study concerning test processes and test process development? Well, first of all, organizations do not develop their process unless they really need to do so. Testing-focused standards and certificates are not widely spread, even though organizations are positive towards them and applaud their use. Organizations usually collect feedback on test process, but they may completely ignore it if they don't think that their process needs any development, even though the feedback would say otherwise. Software criticality development methods outsourcing are not anymore a large problem for testing, and test automation itself is a double-edged sword. It works. If it works, it's a useful and powerful tool, but if it doesn't, it's a costly misadventure, so organizations either go all in or tend to avoid it. And one misconception leading to several misadventures is that the organizations have a tendency to think that test automation is a frontline testing tool. Of course, it's not that. It's a quality assurance mechanism which aims to make sure that certain parts of the program don't break down. Okay, so the organizations have 2 stereotypical methods of designing a test plan within a project: even risk-based or design-based. And overall, it seems that the test process, test organizations and testing in general has matured. In a sense that the 75% average on test resources is the current survey result. And we have a literature that suggests that 20% is actually enough if it's used efficiently. So unlike earlier results when the test processes were running out of resources and they didn't have tools or the knowledge to do efficient testing, nowadays it's more likely the management and efficiency factors, not the resources or lack of them. And Overall, the test process model defined by the standard is usable in different organizational contexts. The concept of strategy, policy, plan exists in every organization. So, in conclusion, the test policy along with the strategy are the operating plan which define the objectives, methods and resources, the framework on which the organization does testing. On the project level, these objectives, methods and resources become plan, test process, monitoring and control and existing infrastructure, and they do testing work. And in overall, in a normal test process, basically everything affects the outcome. If the test process is exceptional, the outcome also affects basically everything. Okay, that's my presentation. It was a bit long, but we have also web pages, and these things I discussed here are only the tip of the iceberg. We have a web pages, and you can send me email, ask more, and all that sort of stuff. And for this film, I also put this for a second on show. That's the publications we did on this study, which published all the main findings. Then there's the other references, roughly in order of appearance. I haven't made it completely certain that they are, but well, they at least are there. And that's it. Thank you for your patience. Send me an email if you come up with something. Thank you.